Okay, hi everyone. It has been some times. Um, this will be a little bit longer video. We're going to divide this into two parts, and this is going to be the first part. And it is likely that I'm going to reference a lot of my past videos. Again, you can find the links down in the descriptions. So let's get started. First, I want to talk about this thing in the past, one of the past videos where it create conduit from one point to another point, following the short path of a existing cable tray network, um, like what we're seeing here. Um, I want to mention this because I find this website, the this website showing a good trick regarding how to find the shortest path. It is over here. Apparently, you really don't need to write a script to find the shortest path. Uh, Revit can just allow you to pick it. So if we look at over here, let's minimize this. If say I'm in the example going from this part, this tray element to this tray element, I select this one first, click tab, like select this tray, hover over that one, and click tab for once. See, it picked up all the things. I just control add. Now I select all these 17 elements. So it works in all of these cases. I can just click tab, and then control select. Allows me to pick all of these. And then obviously in Dynamo, there's ways to pick up the current selection, which is these tray and fitting element. So I can use as the path to calculate the path of the conduit, which means, sadly, if you look at this script, like all of this part, this first half is regarding to find the shortest path. So at this point, all the way until here is still finding the shortest path. All that can be replaced with, say, get selection. Yeah, something like this. Get Revit selection, and you just pass that in, and it will fix all of this. It's good to know. Uh, the finding the shortest path is still helpful, and it still helps you find the second shortest path. Besides, I've learned that it is a little bit different when it comes to the way Revit recognizes the shortest path. For example, if I want to find from here to here, I click tab and plus selection. Revit kind of thinks this is the shortest path, where I'm pretty sure if I can go this way, it's shorter. I just don't understand why it is not picking up that. Maybe the shortest path is following some other kind of algorithm which treated bend very much differently. But in any case, I would say in most of cases, this trick, this click, hover over, tab, and control selection will work just fine to pick the shortest path for most of these scenarios. So yeah, there's this, some past, uh, some new information from a past project. And for today's project, it is actually inspired by um, a 2017 hackathon project called Revelations. They have a GitHub And here's what they did. Let's see this one. Basically, you pick a set of furnitures and you create some pad. It will replicate the same devices across these furnitures. The same kind of furnitures across the same pad. Well, it is and it shows like if you move them around and it can be upgraded to match the parent-children relationship. Well, so this is very interesting, and I decided to take it into a little bit work, and because really in the past we have done a couple different ways to do something similar. For example, this one will recognize a furniture, in this example a desk, and allows us to place the chairs around all the other existing desks. Well, let me tell you that there is a lot of problems in regarding to recognize the different furnitures, may be a type or a whole family, and the furniture may exist in different phases and work sets and even design options, making it a lot less reliable. And also, like here, this is the project we're going to show today, where I'm taking the rooms and creating a referenced card so that I don't need to model every single rooms. I can always have them reference to the same room layout that I already have. So all of this will like add on to today's inspirations. And here's what I got: the same model where like to the actual building, there's nothing in there, and I have some furniture layout showing what is here already. And here I'm introducing this annotation markers showing that I want take what is in this room and put it over here where I have placed the same annotation markers. So I have a couple other things just scattered around these rooms. We're just going to do a couple of them. I'm not going to show all of it. And here's how it does. I can just go ahead and run. So this one is taking the existing room as the boundary, instead of creating a new pad as the revelation the revelation project's doing, and is recognizing all these furnitures and try to place them around the buildings. It's a little bit shady, and the first run, I can run it again. It will try to like for some kind of bug is slightly off every time I run it for the first time, but we built it so that it runs the second time and try to correct itself. So now you see this is a little bit better, and well, it's still a little bit shady. And also, like if it is good enough, it also turns this into halftone. I can run this again. Eventually, like all of these will turn halftone. And the same kind of goes like if I come here and delete this. And say I run this again, it will propagate to the other rooms. Now that table desk, the bedside desk is gone. Well, we're not going to go too deep into how this is done. We're going to save that for the second half of the uh, this video. But we do want to say that this is also like taking up a lot of my other old projects. For example, the snap to wall, and also like it will need to recognize that I've changed, say, a type parameter. Now I've made this pad a little bit bigger, therefore it will allow me to push that information to the other rooms. So see that pad has been turned bigger. This is obviously taken from a past example where I try to merge duplicate families, where we talk about there it is looking for all these editable type and instance parameters and essentially in the very end match those common parameters. And also if we recall some past examples where the snap to wall allows us to put something relatively closer to wall, and if I wanted to snap to, it will be able to essentially find the wall that is most close to, and here is snapping to the wall. So overall, this is trying to say that this is a little bit longer project, and it relied on a couple of my past examples to make it fully operable. But for today's main topic, uh, we're going to talk about that deeper in the second part. But for today's examples, I want to talk about something else. Basically, like a little thing I noticed this time. So if we look at here, for this example, I've created a lot more custom node than I used to do. And this is why, and here's why I've noticed that it's becoming a kind of uh, like new realization for me. So I'm going to be opening a new project, and I think this is some kind of uh, problem on how Dynamo works, and we're going to show you how and why. So basically, we're going to start a new project and start a new Dynamo file. And let's do file from path. Oh, this is actually probably the first time I actually build something in the video. Bear with me, this is going to be fast. I've had a existing Excel file where I'm going to read. This existing Excel file is just a list of random numbers, list of 1000 random numbers, which we're going to use as point list to creating elements. So I can just build it this way, and now I create a bunch of point and say family type by point level. We're just gonna pick anything. I don't know, desk and level. We're not going to create that right now. Once we create these, get location. So here is done. It's a very short piece of scripts where read a bunch of point and create a lot of families, and then finally I'm sorting them on the X location value. So if we fit this in, we'll see it will finish relatively quick. It's a couple of seconds. It create here 1,000 desks, all scattered, cluttered in here, quite clumsy. But if we look at this, see, like somehow it fit in all the location as zeros, even though we are seeing that they are created in different locations and they are reading the locations from the Excel, which is quite unique one by one. And therefore, the rest of these things didn't really work. It's not sorting element because the point didn't come in. And if I untouch that and touch it again, it will pick up like the actual locations and sort accordingly. The point X now has values and the sorted ones actually sorted. But if I just unplug it from here and well, that will take away all the desks. Now they're gone, and plug them back in. Still, these are all zeros. The same goes for if I just unplug it from here and any case, it would seem that when the list is long, this part of script like kind of finished before it finally create all these families. Therefore, the location didn't come in as quickly as possible, and therefore the rest of the script is essentially useless. It has to be refreshed or rewrite there in order for it to properly function. And that's not the most ridiculous discovery that I have. It is this. Now we look at this and see that it actually kind of finished in a couple of seconds. What we're going to do is we're going to save this. We're going to tell this as arrow diamond. Save and close. Let's get rid of these. I'm going to file up Dynamo again. Close the Excel. I'm going to open that one I just created. Open in manual execution mode. Now, for example, I kind of detach it from here and go run automatic. It will say complete. It opens this up. Now we remember that everything finished within a couple of seconds when we first create this. Watch here when I plug this in, and it's going to start spinning and basically never going to finish for a quite long period. So that's what get me frustrated the most. And apparently, like, it just stuck there for a tremendous amount of time. And if I get boring, it's probably this one, and decided to terminate this. And say if we come back here in another Revit session, start another new project. And repeat this process again. We're going to show you how, like, basically I find whenever a existing Dynamo script gets stuck in a loop or just never finishes, and I've decided to terminate it, essentially it will never be as fast as it was before. So exactly the same script, go open. What used to finish quite fast, now if I still unplug this and go run, complete, it picks up all the point, and then connect this in, go run again. Basically, when we first built it, it complete within a couple seconds. Now it will never finishes, not for a couple minutes, even 10 minutes. I have no idea why this is happening, and basically getting a existing script into a loop is very easy when we try to create them from scratch. But once they caught in a loop, they will never run as fast as they were before, as if some cached script is looped there and causing this whole thing to stuck. That's the reason I've switched into a approach where I create a lot of custom node, and so that I kind of compartmentalized the testing into small batch of scripts so that it doesn't really so I don't have to rebuild everything. Basically, if I rebuild another script like this, it will function properly and complete within a couple of seconds. But um, now that we have made it stuck once, it's not going to be as fast as it used to be. So that's the kind of trouble I've had. Not so sure as to why this is happening, but as far as develop goes, maybe this is something wrong with Dynamo, maybe this is something wrong with the version I'm having. But anyway, I've switched into the approach of creating smaller batches and save them into custom node so that I don't run into this kind of situation as much as I can. And that's the things I want to talk about today for this part. Basically, what a newer revelation project that I'm making, and the different tricks to create a shortest path, and some new discover regarding how Dynamo scripts works. In the next part, we're going to go deep into how I created my room propagators scripts. There's a couple things noticed and worth mentioning. But here we are going to pause again. See you in the second half. There you go.